Thank you everyone for joining NCBPA and Build Smart today for this great passive house and affordable housing webinar. It's something near and dear to NCBPA's heart, with this sustainable design building, and we are happy to have our member company Build Smart giving this presentation. So please welcome, and just so all of you know, I see some Passive House Committee members on the call today. This webinar is in place of that call that we usually have every month. We wanted to give one of our active members on the committee, Karan Gupta from Build Smart, a chance to share some of their affordable housing and passive house initiatives they have going on, and to see some case studies and real life examples of the passive house market growing in North Carolina. So we are excited to have him on the call today. I'd like to mention that we are recording this webinar, so if any of your colleagues could not log on today, or if you missed something in the presentation, you will be receiving a copy of this recording. And also, I've seen people using the chat box, which is great. I've spoken to Karan, and we want to try to save questions until the end of the presentation. We have a lot to get through today. So if you would like to use the chat box for your questions throughout, or to have questions at the end for a placeholder on a slide you'd like to mention, please save those until the end, but I will be checking the chat box if we need to stop and go over any further content. I have some more announcements that I'll save at the end on NCBPA's side and how to stay involved with the membership and Passive House. But with that, I'd like to just go over the quick breakdown of what we'll be covering today and then hand it off to Karan. So we're going to be covering the shortage of affordable housing that is available to growing urban population and the utility costs of standard building stock. With that, there's a mounting financial pressure from living costs for low and middle income segments of the population. So Karan Gupta, the energy efficient specialist at BuildSmart, is going to walk us through the benefits to architects, builders, and developers of both these solutions, while also providing more specific detail on the BuildSmart panelized wall system. And to wrap up, Karan will also be providing a financial analysis case study. So I got some more people logging on, which is great. Welcome. So we have a lot of great content to cover and to get through. So Karan, with that, if you'd like to share a little bit more about yourself and BuildSmart, I'll turn it over to you so we can go ahead and get started.
Great, thanks so much for the introduction, Abby. So good morning, everybody. Thanks for joining me today. My name is Karan Gupta. You can call me KG. I'm a certified passive house consultant, as well as a FIA certified builder. And I'm project manager at BuildSmart, where we manufacture high performance panelized exterior walls, as well as slab insulation systems. We're based in Lawrence, Kansas, and we ship product all over the continental United States, as well as Canada. Today I'll be discussing the advantages of passive house and prefabrication for new construction, particularly for multifamily developments. Before I go to the next slide, can everybody hear me pretty clearly?
Yep, loud and clear.
Okay, great. All right, so I've got 4 key learning objectives for this presentation. Number 1 is, what are some of the key challenges that call for a manufactured approach to construction? What are some of the benefits of productization of building components? How do manufactured building components work synergistically with passive house principles? And how can design professionals, builders, and developers collaborate with manufacturers to deliver projects that meet stakeholder objectives? Besides a few diagrams, I promise that this will be the last slide I read out loud to you. So if you recall from a moment ago, our first learning objective is to understand challenges requiring new approaches to new construction. I hesitated to include this slide because climate science has become a political hot potato in the last few years, but I think it's important, and it also seems to be a key component of almost any passive house presentation you see these days. So a lot of you might be aware the Intergovernmental Panel on Climate Change, IPCC, released a report in October 2018 outlining the impacts of a 1.5 degrees Celsius global warming. I don't need to describe all the impacts, as I'm sure you're mostly familiar, but the most important point here is that we've got 12 years to take serious action to avoid the most catastrophic effects. Now, I'm guessing at least some of you do this work because you feel that reducing building energy use is one of the most powerful levers for reducing carbon emissions. But regardless of your reasons, according to the International Energy Agency, the global building sector is responsible for 30% of final energy consumption and more than 55% of global energy demand. The building sector is responsible for 28% of total direct and indirect CO2 emissions. But besides carbon emissions, the construction industry generates enormous amounts of material waste, and the built environment consumes the bulk of generated electricity. Increased power demand requires costly investment for new generating stations and infrastructure, as I'm sure a lot of you in the Duke Energy service area might be aware. So moving beyond the climate change imperative, there's a shortage of housing that is affordable, that's available to a growing urban population. For the sake of clarity, I'm using the federal standard of affordability that no more than 30% of a household's income should be spent on rent and utilities. If you compare the required hourly wages to afford a two-bedroom rental unit in each state with a federal minimum wage of $7.25 an hour, you can see on this map that there's a pretty major discrepancy. So this isn't really a time or place for me to launch into political discussion on wages, but it is immediately clear that we have a crisis. I would argue that part of the problem is the lack of incentive for developers to build housing for lower income segments of the population. And while there's plenty of demand for market rate or luxury housing, which is the most profitable for developers, there is a constrained supply of affordable and workforce housing compared to demand for those. During the Q&A at the end of this presentation, I'd love to hear any takes on your viewpoints of this issue in North Carolina, specifically the Triangle. So having outlined the problems, the question then becomes, what is the solution? I think it's probably obvious to most of you without further explanation that passive house is a major part of the answer to reducing building energy use and associated carbon emissions. And we've already discussed the importance of building energy use for the challenges of climate change. But with regard to the housing crisis, there are a number of case studies, as well as an ASTM paper by my colleague Paul Grahovac, showing that passive house can make more money for developers. Under the current economic system, only the profit motive can reliably increase housing stock for segments of the economy that most need it. And I'll discuss this in more detail a little bit later on. So besides being a critical part of the solution to the dual challenges of climate change and the housing shortage, passive house offers a host of other benefits, which are old news to you, but I'll repeat them here to be thorough. There's reduced energy costs, reduced maintenance cost, superior building durability, improved thermal comfort, better indoor air quality, outdoor noise attenuation. It's the fastest path to net zero, and of course, reduced carbon footprint. All of this translates to reduced operating costs and increased productivity and quality of life for occupants of passive house buildings. So then the question becomes how best to scale passive house. There are best practices for any project, but I believe the most important first step for increased adoption of passive house and new building stock is a shift from on-site construction to manufacturing. I may use the term manufacturing interchangeably with off-site prefabrication, which is defined as the planning, design, fabrication, and assembly of building elements other than their final installation location. I apologize if this slide is a repeat for any of you that have seen my last presentation for NCBPA, but what you're looking at here is an auto assembly line. Now, if I told you this photo was taken in 1877, would anybody believe me? I doubt it. But what about this picture? What if I told you this was taken in 1877? Well, I hope you would believe me because it was. But what if I told you it was taken last week? Besides the outdated clothes and the image quality, it wouldn't be that far-fetched, would it? So the question we ask ourselves at Build Smart is, why is the building industry still stuck in the 19th century when every other industry has advanced into the 21st century? So to talk about manufacture for construction or offsite prefabrication, floor and roof trusses are good examples of such products, as well as ICFs, insulated concrete forms, and SIPs, structural insulated panels. Panelized walls are not very different, and the productization of wall components requires product warranties and therefore extensive research and development. What you're looking at here is the Rosetta test chamber, one of 3 in the world, developed and hand-built by Ron Tatley of Rosetta Building Envelope Analysis, which is part of the Prefabricated Buildsmart family. This is a purpose-built chamber for testing building envelope components, including panelized walls, windows, and doors, up to Category 5 hurricane conditions. It's precisely this research and development process where all the magic happens that takes the guesswork out for the architects, builders, and developers. And while a product supplier may not be able to do rigorous code analysis on every single project, they can have available a library of resources, including engineering documents for structural requirements, energy performance requirements, and a variety of other project-specific concerns such as fire rating, etc. There's a reason. Sorry, one second. Sorry about doggo. There's a reason that other industries have moved to mass manufacturing, including economies of scale and highly efficient repetitive processes. According to the National Association of Home Builders, stick framing produces almost 30 times as much job site waste as off-site prefabrication. All that wasted material has real costs, and there's a double whammy when it's time for disposal. The quality assurance of materials delivered to and stored in a climate-controlled factory far exceeds what's possible on a job site. The same is true for the quality control of the finished product leaving the factory, especially relative to building in the field. The end result is predictable, consistent output, and every panel that goes through our line is subject to thorough inspection for square, nailing pattern, adhesion, window or door installation if applicable, and sealant and flashing application. Besides a dedicated QA/QC team, every single worker on the production line is also trained to know what to look for with regard to quality of incoming materials and outcome finishes. Sorry, I lost my train of thought for a second. The whole process is fully documented should there be any questions or concerns after the panels reach the job site. And of course, these details are of particular importance in the context of passive house, as any of you that have worked on passive house projects might know. As I'll demonstrate here, when you marry manufacturing and passive house, the two can work synergistically to deliver better building quality faster and cost competitively. In the field, passive house prefabrication translates to shorter project timelines, meaning quicker dry-in, fewer weather delays, and reduced exposure of materials to the elements. This also means improved building durability and reduced mold risk. The reduced labor costs with their associated risk exposure, as well as burden and overhead for planning specification, supervision, and site operations, can have a significant impact on the project budget. And the importance of cost savings realized by faster site erection cannot be overstated. We've seen erection rates of 200 lineal feet and up in a single 8-hour shift by a crew of 4 with no prior experience using the system. Since the housing market collapse of 2008, the supply of builders and tradespeople has been constrained with an inadequate supply of new talent from younger generations entering the market. At the same time, demand continues to grow as a result of new housing starts and rebuilding efforts from natural disasters, including hurricanes, floods, and fires. The end result is high labor costs compounded in localities with union labor or requiring Davis-Bacon prevailing wages. Conventional construction methods require large teams with specialized trades and multiple laps around a building. Both prefabrication and less training is required to meet passive house standards, and no special tools or equipment are needed. So I'd like to take a moment here to step back from conceptual discussion to practical consideration of an example of prefabricated passive house construction. This here is the most common variant of the BuildSmart panel to date. And if you bear with me while I walk you through the detail and hold your questions until the end. I'll also be including my contact information at the end of this presentation, so please feel free to reach out to me directly for more literature. So I'm going to start from the inside here and work my way to the outside with the framing layer. So what we use in the factory is anywhere from 2x4 to 2x8. And I apologize, the graphic is a little outdated, it's showing 2x12 there. But 2x4 to 2x8 LSL, that's laminated strand lumber, such as timber strand framing. We can offer that with 16 or 24 inch on center stud spacing. Then mechanically fastened to that is a layer of OSB, which is going to form the air barrier. Bonded to the OSB with an adhesive is a layer of continuous exterior insulation. This is termite treated EPS, expanded polystyrene. You can get that anywhere from 2.5 to 11.5 inches thick, depending on your client needs. And then laminated to that is exterior layer of zip sheeting, which has an integrated weather resistant barrier. But then one of the things that really sets us apart from other panelized companies is our pre-installed windows and doors. So you can see what we're calling here our window fit system, which is a pre-flashed return buck made up of zip. And we're using the Prosco fast flash around the rough opening there. And then of course we pre-install the windows and doors into that rough opening with backer rod and air dam to give you a watertight seal. The windows and doors we're using are either clear wall or Alpen. They have a variety of Passive House certified offerings, although we can also use some of the lesser performance double glazed assemblies, etc. So there's going to be really high performance windows combined with continuous exterior insulation, giving you very robust thermal performance as well as easy air sealing in the field. The most important takeaway from the slide is that what you see here is not the limit of the system's capabilities. We have a variety of other materials for each assembly that can be used in a variety of configurations to meet your project specific needs, including fire rating and structural requirements. Also, while we like to see projects go for the goal to meet Passive House criteria, we do understand that there can be a number of barriers for project teams. So to that end, we can offer panels to lesser levels of energy performance. As a final note on the slide, I previously showed you our Rosetta test chamber. And if you have unique project needs, we're excited to work with you to potentially develop new offerings, which we then put through rigorous testing before fabricating anything that leaves our factory doors. It was through this very process that we developed the 1-hour panel that is currently being used on multifamily development in Philadelphia. And it was within a month of pricing that variant that we were fabricating it. So in addition to a panelized wall system, BuildSmart also offers a slab perimeter insulation system called JFerme. The system is designed according to ASCE 32 for frost-protected shallow foundations. These forms constructed from EPS facilitate a simple pour for slabs while also providing continuous insulation. And before any wise guys pointed out to me, I know that this graphic is a little dated and the vapor barrier should be in below the rebar at the slab edge. So we are working to revise that. We'll have that up on the website. So what you're looking at here is, I don't know if you can see my mouse here or not, but this piece of the edge of the thickened slab edge is the J-form. And what that does, it provides form for the pour in addition to insulation at the edge of the slab. You can lay in the vapor barrier over the top of that, set the rebar with plastic chairs, and pour the slab. Now the J-form is used in conjunction with underslab EPS to provide a continuous thermal layer around the entire building envelope, which you can see out to the left over here. And then of course you need to take your gravel down to frost depth and put in the drain pipe, or alternately you can also use it with skirt insulation as long as the skirt goes out to the same length as the depth of frost depth. And then of course preformed EPS perimeter insulation eliminates the need for a backhoe and also requires less concrete. So now that you're familiar with the panel assembly and the J-form system, I'll give you a brief idea of how it all goes together. So you can start from the bottom here, and you can dig your trench for your gravel pour. You've got your drain pipe. J-form goes in with a vapor barrier, and the slab is poured. and then there's a field installed bottom plate that goes in, and you're going to use the Procycle R-Guard joint seam filler at the bottom of the panel, right at the OSB layer, which I mentioned earlier is the air barrier. So in between every panel and the bottom plate, as well as the panel-to-panel connection, you're just going to apply a continuous speed of that joint seam filler, and that's going to give you your complete air barrier around the envelope. Then at your floor systems, we provide what we call a band, which is essentially a SIP. It's just a lamination of OSB, EPS, and zip, and that kind of continues your panel assembly over the edge of the floor system. And then if you have a multi-floor project, the next set of panels goes right up on top of that. And then again, the roof system, kind of similar to the floor system, we provide a roof band, and those can be pre-cut to angle, or we can provide them flush and you can cut them in the field. So that's kind of the quick version of how it all goes together. Okay, so hopefully having established prefabricated passive house is a desirable approach and having familiarized you with how the system works, how do we design for manufacture? I'm sure a lot of you have seen this diagram before. Just as with on-site construction, an integrated design process is more important with prefabrication because decisions do need to be made earlier in the design process. Late stage changes in on-site construction are relatively easier to implement. Determining the project specifications and choosing the right product and assembly for the project early in the design process is critical to realizing the benefits of shorter construction schedules offered by prefabrication. In so doing, manufacture can take place at the same time as building permit approval. I'm sorry, give me a second here. Sorry about that. So as I was saying, at the end of the design development phase, the manufacturer Okay, so I was saying, by optimizing your project delivery schedule, you can get the site clearing, excavation, and preparation of the building foundation taking place in conjunction with the fabrication of the panels in the factory. The prep work can add up to several weeks, and that way you can have the panels delivered right as the foundation is being set to kind of keep things moving along smoothly. So this diagram here is a simplified workflow of how the design process might work for a new project utilizing manufactured components. Again, early engagement between architects and manufacturers will ensure the best project outcomes. And we've seen projects aiming for passive house end up getting built only to code, simply because of a failure to engage all stakeholders early on. There's a specific example where the lender was actually the barrier at the end of the project there. So schematic designs are useful for the manufacturer to provide initial feedback, particularly with regard to design intent, energy performance requirements, air barrier continuity, and other details requiring special consideration for prefabrication. At the design development phase, the manufacturer can offer input on value engineering to optimize cost and performance, and it's at the stage that the manufacturer can also provide preliminary pricing and estimated lead times for delivery. Once construction documentation is ready, final specifications, code, structural, or fire requirements can be confirmed, and then pricing will be issued, a contract is signed, shop drawings are produced, and fabrication begins. A site visit can also be coordinated with product delivery to the job site to assist with installation, though this is not usually necessary given simplicity of the prefabricated components. The goal throughout this collaborative process is to provide an easy button. This slide is for the architects here who have apprehensions about the design limitations of prefabricated wall systems and are thinking of manufactured products with very limited options. Fortunately, car manufacturers have progressed from any color as long as it's black to the strategy today of packaged options. In the upper left corner, you can see the old model that you may think of with fixed modules, and that's actually a graphic from the BuildSmart website as of just a few months ago. The present condition is on the bottom left, bottom right, and if you go to our website, you can find more information. But the idea here is that progressive manufacturers are moving rapidly to computer-driven production equipment that can cost-effectively offer mass customization within some limitations to meet a range of design intent. This here is a sampling of BuildSmart projects, some completed, some in progress. You can find more information on completed projects on our website, as well as new projects are completed. And the point here is to show a variety of building types and architectural flavor possible with prefabrication. In the middle row there, on the far right, that's the 1 hour panel I mentioned earlier that we started fabricating within a month of pricing it. So that was a pretty quick burn on the development of that product offering. And you can kind of see some of the different building types there. There's a school, a number of multifamily projects, large apartment buildings, townhouses, as well, of course, as single-family residences. So I'd like to turn your attention now to a case study featuring prefabricated passive house wall panels. You can see a little bit of project information at the top there. The project was called the Whitehall. 49 unit affordable housing development for veterans in Spring City, Pennsylvania. And this is the project that was the basis of Paul's ASTM paper that I referenced earlier. Through early engagement between the manufacturer, builder, developer, architecture team, passive house consultant, and HVAC engineer, the project was a resounding success. You can read the bottom line for yourself. Cost-effective panelized passive house building shell construction has been demonstrated along with operational profitability. In other words, this is a project where the incremental cost between code minimum and passive house was shown to have less than a 5-year payback, which is a pretty excellent low-risk investment. So after completion of the air barrier, preliminary blower door test yielded a result of 0.5 ACH on the first try. Now again, for anybody out there that's built a passive house before, you know how significant that is. The developer was also able to lower the tenant utility allowance owing to the significant reduction in operating energy requirements for the building and the increase in prospective rental revenues and expected operating income allowed for greater loan funding availability and developer fees. In this case, as a nonprofit organization, the developer will plow the additional fees back directly into the construction of more affordable housing. For private market projects, developers can pay tenant utilities and divert revenues from energy companies to the developer. If anyone would like a copy of the paper referenced here, please email me requesting it, and I'll make sure to get a copy out to you. BuildSmart's been having particular success in the Pennsylvania market owing to the availability of low-income housing tax credits for developers achieving passive house certification on their projects. I won't go into the specifics of how that process works, but there are a number of other states that now have similar incentive schemes in place and several others that are nearly committed. I'd like here to call out the efforts of Ryan and Abby and the rest of the NCBPA team in adding North Carolina to the list. In addition to compliance requirements by way of more rigorous building codes, financial incentives can go a long way to improving the quality of new building stock throughout the state. To the extent that any of you on the call here are involved in those efforts, thank you also for your work. And lastly, while passive house has been the focus of my presentation, there are a number of other building standards and certifications for which BuildSmart can help meet your objectives. Note that in the graphic on the bottom right corner, some of these certifications are necessary for passive house. I realized I went through that pretty quickly actually, but I did want to leave a lot of time here for a Q&A at the end. So thank you all for attending on a Monday morning. Please do get in touch if you have further questions after today, or if you have projects in any phase of development. We'd be happy to look at those and help you value engineer, as well as provide price estimates if you'd like those. So with that, I'll be happy to take questions now.
Great. Thank you so much, KG, for a wonderful presentation that I learned a lot. I just found that with more and more passive house resources and information out there, that it's a huge market that I know that I love learning about, and a lot of our members do as well. So I don't see any questions as of now in the chat box, but I will go ahead and unmute everyone. So if you've got any background noise going on, we'll be able to hear you. So everyone is unmuted. If you would like to ask KG a question about the presentation or any follow-up that you all would need.
And Abby, this is Ryan. I think maybe to kick things off while we're waiting for a question or two, I think, KG, you mentioned briefly some of the efforts that we've taken on at NCBPA, and so I just want to mention it very briefly. You know, the Housing Finance Agency, of course, offers incentives for developers that, you know, install different measures that, you know, improve, you know, lower tenant rents and obviously a lot of other things. But, you know, the only real energy efficiency or, you know, kind of water efficiency program that they have is just the Energy Star version 2 standard. I mean, that standard doesn't even exist anymore. It's not supported in any form or fashion. So just a couple of months ago, our members know that we, you know, had submitted public comments for the 2019 QAP Qualified Action Program, our plan, to try to implement incentives for developer that would be, you know, based on HERS points per unit, or, you know, a passive house certification, or even principles, water fixtures, toilet efficiency, LEDs, a lot of different things. We weren't able to get really any traction on that. It was sort of a, you know, throwing the rock over the fence kind of a situation. It just sort of landed with a thud. So we're going to be, you know, ramping up those efforts in 2019 from a couple of different avenues, but the point is certainly to implement different incentives for developers to push them towards more passive house type construction fundamentals and hopefully certifications. So just a quick mention on that one.
Great, thanks, Ryan. I got a question from Adam here asking about the old Build Smart modules versus the current panel offerings. So the way it used to work is you see these modules in the upper left, and these were what we were calling our standard panels. We had these available for download as SketchUp and Revit components, and you could create your structure using these. There were 1, 2, 3, 4, 6, and 8 foot widths, available at 8 and 9 foot heights with limited window and door offerings. Since then, in just the last few months, we have new design software that's been integrated with new manufacturing equipment out on the factory floor that basically allows us to do mass customization. So there are some limitations, of course, and really the overarching one is actually shipping limitation. The flatbed trucks that we ship the panels on have a height limitation of 9.5 feet. And then the for onloading and offloading the skids, we have a maximum width of 12 feet. The graphic I'm showing you here actually has also been updated. The most recent version is on the website. But it basically provides some guidance. So you no longer have to use those components. You can actually kind of draw something up from scratch, as long as you just bear in mind kind of the height limitations and the placement of the windows with regard to panel edges and corners. You don't have to worry about where the breaks occur between panels. You just create a design, you send it to us, and if it goes to the manufacturing phase, we'll actually optimize the panel breaks for you.
Great, thank you, KG. I have another question from Jarrett, and the question is, how do you achieve the 1 hour rating with wood framing and EPS insulation in the assembly?
Great question, great question. So the assembly we're using there, keep in mind this is a 1 hour exterior rating. And while you're probably thinking of EPS, you might be thinking of it in the context of the Grenfell Tower fire in London last year, I believe. Yes, under fire, that EPS is going to melt and the cladding will come off the face of the building, but the 1 hour rating is specific to preserving the structure. So the requirements, we have some engineering documentation to back this up, and if you email me, I can send that to you. But essentially, all that's required to meet that 1 hour rating is that your 2x6 stud framing be at 16 on center, and that you use a product, Louisiana Pacific product, LP flame block. So one side, it's OSB that on the exterior face has a magnesium oxide coating that provides that fire resistance.
Great, thank you. Are there any more questions? We got a few in the chat box, but I think we answered most of those. Everyone, like I said, is unmuted, so if you have a question you'd like to ask, feel free, and we'll wait a few more seconds for any coming through the chat box. Oh, Jarrett has another one. Are you currently only doing wood-framed passive walls?
Yes, that is correct. So at the time, we're only offering wood frame. There have been some thoughts about using light gauge steel framing, but you know, as a relatively young company, we're trying to perfect the wood frame walls first. That would require a whole different set of factory equipment to produce steel frame walls. That being said, we are working currently on prototyping for a 2 hour wall. Hopefully that'll be available by the end of the year, but it is a much trickier thing to solve for. I see another question here from Peter. Are you using stud space insulation in the framing? And Adam, thank you for answering that. Yeah, that'll be done in the field. So what we provide is an open stud cavity, and once the panels are installed on the job site, the beauty of our system as compared to SIPs, for example, is that you have a traditional stud cavity that's familiar to the trades. So, you know, once the whole building is up, it's going to look just like conventional construction. There might be a few more studs where you have the panel joints, but, you know, you can run your wiring and everything else, and then you can insulate those cavities, and you can use whatever you want. You can do spray and bat, you can do fiberglass, you can do blown cellulose, whatever you want to put in there, mineral wool. So good questions. I know you got some more. Slab insulation system, two-part insulation system. Okay, let me go back to that slide for you. Okay, so what's going to happen here, let me see. I have some photos I can show you. So you're going to dig your trench and pour your gravel and kind of excavate where the entirety of the slab is going to go. Completely installed. Yeah, let me see if I can find one for you. Give me 1 second here. Should have something like that. Is everybody here familiar with frost-protected shallow foundations? That's kind of the idea of what we're trying to achieve here with the JFerme system. So there's a document called ASCE 32, and it essentially allows for, you know, so you don't have to dig deep footings or stem walls. It basically allows you to do a shallow foundation like the one in the picture here. Let me see if I can find this picture. All right, here we go. Let's see. Oh, good question, Peter. So yeah, the problem in northerly climates is frost heaving. And again, so long as you're going down to frost depth with your gravel trench and you put your drain pipe down there, you should meet those requirements. We have had some code officials on specific projects that have pushed back. And there was one specific example in Minnesota. And what we had to do for that one was we just provided an additional piece of EPS to provide a frost skirt, despite the fact that the drain pipe was already below frost depth. And that was sufficient to satisfy the code official. Let me get some more pictures of this up here for you. So as you can see here is after the underslab EPS has been set and the J-forms have been staked in place. The vapor barrier has been laid down and rebar set up. And from here on, you're just going to pour the concrete for your slab. Let me see if I can find you some pictures earlier in the process. So this is kind of as it's coming together. You can see the J-forms, the gravel, the underslab EPS. This is kind of an interesting example because you can see it's almost above grade there. Let's see what other pictures do I have. And here's another one. So this is kind of after the slab has been poured. You can see the exterior face of the J-form. And there's also a piece of infill EPS. This is a 3-pound density that's going to go along the edge, and that's going to fill in between the J-form and the bottom of the Build Smart panel, where you have your field installed bottom plate. So it's kind of making up that gap over there. Were there more questions about the J-form?
We do have a question from Jarrett that I don't want to skip, and there's a lot going on in the chat box, and we may have already addressed this, but how do you seam the wall assemblies together during installation for shear value, since the sheathing is already installed at only the max panel widths?
Let's see. Could you read that to me one more time? Oh, I got it. I got it right here.
Got it? Okay.
Okay, that's a good question. So as far as the sheeting that's applied in the factory, the OSB, typically we do 6-inch nailing pattern at the perimeter of the panel, and within the panel, the vertical studs get a 12-inch nailing pattern. Now, if you have specific shear wall requirements requiring a tighter nailing pattern, we can provide that. We can definitely do custom nailing patterns for that. And then as far as when the panels go together, panels that are installed at the slab are held in place with bolts that go down through the bottom plate into the concrete. And then from panel to panel, we use 3 1/4 inch, I'm sorry, I think it's probably 4-inch lag bolt to hold the panels together. So with a joint and seam filler, the OSB layer plus the lag bolts holding the stud framing together, you get a really robust assembly. And then, of course, along the top of the walls, you tie all the panels together with another field installed top plate.
Hey, Karan, this is Adam Stetton. Nice to meet you.
Yeah, likewise.
I back in maybe 2013, I had a house plan, and then I sent it to Adam Cohen, and we went over it, and it was not very friendly to the stock system, and we have since had a couple kids and not built that house, and now this is kind of music to my ears, kind of the mass customization thing, but we were talking about all the windows and doors. You know, are all the windows that indoors that you're providing for most of your work now, are they all that triple pane with that, like the hinge out, tilt out, that system, or what are you guys using now?
The tilt turn. So yeah, we have offerings from both Clearwall and Alpen, and the types of operations that we have available are tilt turn, which is going to open inward. You can get in-swing or out-swing casement, hoppers, awnings. Really all we don't offer is sliders and single or double hungs. And again, that's because we just don't want to warranty the factory performance on those. They just don't have as good seal for airtightness. Now, as I mentioned earlier, there's a variety of offerings available from both manufacturers. Generally speaking, if you're going for passive house, we're going to go for a triple glazed, or in the case of Alpine, it might be a double glazed with a suspended coated film that simulates the performance of a triple glazed. But you know, we have value engineered projects that might use double glazed windows, and especially for some of the larger multifamilies, we're starting to see some of the kind of R value or U value requirements step back a little bit depending on the climate, as we find that larger building volumes require less robust thermal envelopes. So again, in the case of that front flats project, we value engineered with them and ultimately determined that we could achieve passive house according to their PHPP model using a double glazed Alpine window.
Thank you.
Absolutely. And there's also some additional guidance, design guidance available on the website. It'll be in the same place where you're going to see the limitations of the panel parameters. There's also some guidance on the window dimensions there. Email address, yeah, let me get to that slide up for you here.
KG, you've got one more question in the chat box when you're ready.
We'll be able to get a copy of these slides and more designing the system. Yeah, I can definitely make these slides available. I'll send them to Abby at the end of the presentation. I hope it's helpful because it's mostly just pictures. But also, if you do go on the website, all the stuff I showed earlier with regard to the diagram of the wall assembly, how the whole system goes together, the JFerme, all of that is available on the website for download. As far as floor and roof systems, we don't provide anything for that. The way we look at those things is they're commodities. You can probably source them locally for much cheaper. And at the moment, we don't really have any kind of added value to offer in those systems compared to the exterior walls. You know, roof systems, the warranties required for those, there's a lot more kind of hoops to jump through there. So that's why we're not offering those at the moment. As far as design manual, there's really not a whole lot of limitation. Again, that's going to be on the website. I was just mentioning to Adam the panel parameter limitations as well as the window offerings. That's going to probably give you most of the guidance you need there. If you do have further questions, you can call me. The phone number listed here is actually going to go to the front desk, but if you'd like, I can provide my direct line. I'll give everybody a second here if you want to write that down. And that's going to be 785. I shall punch it into the chat box here too. It's going to be 785-331-1024. That's my desk. And I'll also give you my cell. It's going to be 919-491-7719. Just put my email address in case you need some slides.
Great. Thank you so much, KG. We are almost out of time. We've got about 5 minutes left if we have any last minute questions.
Do you have any projects? Do you guys have any projects currently in the Raleigh area?
There is one single family in Chapel Hill.
Who's building that one?
It was Kevin Murphy of New Fire Building Corp.
Okay. Yep. Man, that guy's on top of it.
Yeah, he sure is. I started with him when I first got into Passive House before I came out to Kansas to work with Build Smart. But yeah, we're really hoping to see some more multifamily take off in the state. Again, I'm really curious about how things are looking in the Triangle right now. I'm from the area, but I live in Kansas City now. I was home last in October, and every time I come back, it just blows my mind how much new construction you see. Lots of the, student housing, mixed use developments, business parks, all that kind of stuff.
Karan, I think you're the same person, but do you remember the weatherization project on Dacian Road back in the day? Is that you?
I sure do, and yeah, I do remember working with you. I still have your business cards. You got a little gecko on them, I think.
Yeah,
Yep.
that's awesome, man. It's I'm not involved with the USGBC anymore, other than just being happy that they're around. But yeah, and I've gotten off my HOA board and everything, trying to just keep focused on certain things. But man, this is really cool stuff that you guys are doing, and I've always intended to try to use this system when I finally build my dream home, and hopefully we'll be doing that in the next couple of years. But it's awesome, man. Keep up the good work, and I'm glad you're in good hands over there in Kansas with these other nerdy people like yourself.
We appreciate that, Adam, and I really hope the mass customization gives you some more design flexibility when you do your home. So we really look forward to working with you on that, hopefully sooner than later.
All right, man. Well, thanks a lot, KG. You're the man, and keep up the good work.
Thanks a lot, Adam. You have a great week.
See you. Bye.
Bye.
Well, that is true. I will reiterate that KG is the man, and I want to thank you for your involvement with promoting Passive House and the affordable housing market within North Carolina with NCBPA. And with that, I'm just going to wrap up with one announcement. And Ryan, if you'd like to speak to this as well, we are hoping to host a summit in mid to late March in 2019 with Passive House being a thread or track in that summit, and are hoping that people are willing to be involved in helping either exhibit, present, or organize in that summit, both in residential and commercial Passive House. So we are hoping to host that event in mid to late March to keep the conversation of Passive House and the involvement, the momentum going forward within 2019. And I'll also be sending some follow-up on wrap-up projects for 2018 of Passive House at the end of the year to our committee. So if you would like to be involved in the Passive House committee, please reach out to me. You'll be hearing from me with a recording of this webinar and all of KG's information as well as a follow-up. But if you'd like further information, please let me know. And with that, Ryan or KG, if there is nothing else to add, I thank you all for joining us today. Like I said, you'll be hearing from me very soon with this information, and I hope everyone has a great week.
Thank you.
Thanks, KG. Appreciate your time.
My pleasure.